Fixed and variable loads. Fixed loads are always present in the structure. Their value, direction, and position do not change. They correspond to the weight of the elements that make up the structure itself. Among others are the weight of the concrete and steel that make up this building. Variable loads are forces whose intensity, direction, and position do change over time. We distinguish two subtypes. Loads of functionality. These are forces that act on the structure and are directly related to its main function. For example, the weight of cars on a bridge or the weight of this load on this crane. External actions. They are the forces mainly related to the wind, snow, thermal expansion, or earthquakes, for example. The difference between force and effort. We call force anything that tries to break, deform, or displace a structure. Force is normally measured in newtons or kilogram force. We call effort the internal reactions that appear in the interior of materials when they are subjected to a force. To calculate effort, we divide the force by the area. It is normally measured in newtons per meter squared or kilogram force per centimeter squared, but we can also use whatever multiple or submultiple of these units. For example, a mass of 100 kilograms above a section pillar 5 centimeters squared will cause an effort of 20 kilogram force per centimeter squared. The same mass above a pillar that is 50 centimeters squared will cause a smaller effort of only 2 kilogram force per centimeter squared. Types of effort. Traction is caused by two opposing forces acting in the same direction and trying to lengthen the structural element. Compression is also produced by two opposing forces as well, but now we're trying to shorten the element. When a slim element, that is long and thin, is subjected to compression, it can sometimes bend to this effect that we call buckling. A shear effort attempts to break or section a material by applying forces parallel to its section and very close to each other. Bending occurs by applying forces parallel to the same direction, but this time are very separated from each other. A bending effort attempts to bend the longitudinal axis of a part. Torsion attempts to twist the material around its longitudinal axis, but without bending that axis.